Diagnosis of suspension, steering, and tire wear problems has been prepared to help you diagnose and correct problems of tire wear and other problems in the steering and suspension systems, and will explain some special procedures you must understand to avoid repeat repairs. For your convenient reference, Dealer Technical Service Bulletin number 77, IM2, summarizes the material we will cover and provides references to appropriate sections of the maintenance manual. It's most important on any steering, suspension, or tire wear problem to make a preliminary inspection of all the moving parts. Any condition of wear, looseness, or binding will affect alignment and cause problems. Make the inspections even if you think you already know what's wrong. Begin your trouble diagnosis then by inflating all tires to the proper pressure. Improper tire inflation is a major and often overlooked cause of tire wear and road instability. The correct pressure for steel-belted bias ply tires is 60 psi. For general jumbo steel-belted radials, it is 65 psi. Next, check, and if necessary, adjust the ride height. Drive the vehicle onto a surface that you know is level. Check the rear ride height first. On both sides of the vehicle, measure from the top of the slotted hole in the frame rail to the floor or ground level. It should be 11 and 11/16 inches, plus or minus 1/4 inch. If the height is incorrect on either side, adjust it at the height control valve arm as described in the maintenance manual. Then, measure the front ride height, also from the top of the slot in the frame rail. It should be 13 and 1/8 inches, plus or minus 1/4 inch. If an adjustment is required, be sure to use special tool J22517-02 to raise or lower the rear anchor arm. Otherwise, the adjusting bolt threads may be stripped. And if you can't adjust the vehicle to the correct height, the anchor arm will have to be changed. There are 3 selective anchor arms with different angles. Use the 23-degree arm, the one with the white dot, if the vehicle is too high in front. If it's low, use the 25.5-degree arm, the one with the blue dot, or the 28-degree arm with the yellow dot if it's extremely low. When the anchor arm is removed, you should disconnect the crossmember and remove the torsion bar to inspect the lower control arm for galling, bulging, or splitting. Also, see if the torsion bar is worn at the control arm end. Replace any parts required to correct the problem. If the torsion bar has to be replaced, it is identified by either an L or R, representing the left or right side at the vehicle. This identification is found at the front end of the bar along with the last 3 digits of the part number and the torque directional arrows. After the ride height is satisfactory, check the shock absorbers by pushing up and down on the bumper ends. Both sides of the vehicle should have a comparable bounce rate. In case of doubt about the shock absorbers, perform the test recommended in the maintenance manual with the lower mounting disconnected. Replace any shock absorber that doesn't check okay. Next, measure the radial and lateral runout of the wheels. Determine if the wheel has any wobble or out of roundness in excess of 3/32 of an inch, or about 94 thousandths. If it does, replace the wheel. Incidentally, if you don't have a dial indicator readily available, the maintenance manual shows you how to improvise a runout checking tool, and it has complete instructions for runout testing. During the wheel runout check, check for dragging brakes at all the wheels, since this can cause steering control problems. Correct dragging brakes by following the maintenance manual procedures. While the vehicle is still raised, check the front wheel bearings. Be sure they're not worn. Check all the front suspension ball joints to be sure they're tight and cotter keys are in place. And also check all the steering connections for tightness. Be certain the steering mechanism operates without binding. Now, it's important at this point to properly analyze any wear that appears on the tires. Some kinds of wear occur simply because of driving habits, but camber wear or toe wear call for checking and correcting the wheel alignment. A front-end alignment should always be preceded by checking the intermediate relay rod for parallelism with the front axle. The reason is, if the rod is not properly parallel, it will cause a dynamic or operating misalignment that won't show up on the alignment machine with the vehicle static. And if uncorrected, the faulty parallelism will cause uneven wear on the front tires, the same as incorrect toe adjustment. There are two reference points for checking the intermediate rod parallelism: the lower control arm front pivot bolt on each side and the flat surfaces near the relay lever and idler lever stud nuts. Once again, the vehicle must be on a surface you know is flat, and the front ride height must be correct. Then measure from the 4 reference points to the floor. Start at the left side looking forward from under the motorhome and measure from the flat surface of the relay rod to the floor and from the center of the pivot bolt to the floor. Subtract the pivot bolt height from the flat surface height. The difference will be about 2 inches. Be sure to get it exact and write it down. Then take the same measurement on the right side and again subtract the pivot bolt height from the flat surface height. Now compare the differences on the respective sides. The left side difference minus the right side difference should be 1/8 or 125 thousandths of an inch or less. If the difference is greater, the rod is out of parallel. To correct the condition, install 2 hardened steel washers under the intermediate rod idler lever pivot to raise the idler lever. Tighten the pivot bolt nut 85 to 110 foot-pounds torque. After you know the parallelism is correct, the front-end alignment caster, camber, and toe can be checked and set. Refer to Dealer Service Information Bulletin 76 IM5A, dated February 1976, for correct specifications for front wheel alignment. There has been a change in the front adjustment specifications. In 1973 and 1974, the adjustment was 0 toe. For 1975 and later, it is 1/8 inch toe out. There are both camber and toe checking and adjustment procedures for the rear suspension. These also are covered in Bulletin 76 IM5A and in the maintenance manual. The first items to check in this sequence for suspension and tire wear diagnosis are the rear suspension bushings. There are 2 service bulletins covering the suspension bushing service and special tools required. Bulletin 75 TM4 covers early models. Bulletin 75 TM23 covers current models. To check for bushing wear, raise the vehicle and exhaust the suspension system. Then, measure the amount of inward and outward movement of the arm at the spindle. If it moves 1/8 inch or more, replace the bushings. Earlier vehicles used a 1 1/4 inch Teflon-lined bushing. Later, this bushing was serviced by replacing it with a 1 1/4 inch bronze-lined bushing. After model serial number TZE06 4V101010, a 1 1/2 inch bronze-line bushing is used in production. Service Kit 723-332 should be used to convert earlier models to the bronze-lined bushings if the bushings are worn, as covered in Service Bulletin 75 TM4. Remove the control arm as described in the maintenance manual to service the bushings. It is not necessary to remove the spindles. Anchor the arm securely in a vise and use the special tools recommended in the respective bulletins to remove the old bushings. Install the new bushings with the special tools shown in the bulletins. Then, use the specified reamer to ream the bushing inner diameters to size. Always turn the reamer clockwise with a hand wrench. After the reaming is completed, clean out all chips with an air hose, and the control arms are ready to be installed following the maintenance manual procedures. Remember, use the bronze bushings to service all models, and refer to Bulletin 75 TM4 and 75 TM23 for the correct special tools to do the job. Misalignment of the rear suspension frequently causes the inner tread of the tire to be cupped or feathered, or may cause camber wear. Both toe and camber should be checked before taking any corrective action. Start by checking camber on a level surface with the ride height and tire inflation corrected first. With an accurate gauge, measure and write down the camber for all 4 rear wheels. Rear tires are set with a slight positive camber, meaning that the top of the wheels may incline outward. The specification is 0 to 1/2 degree. If the camber measures negative, you correct it by adding horizontal shims behind the suspension mounting bracket, or you would remove shims if the positive camber is more than 1/2 degree. However, wait until you've also checked toe, since vertical shims may need to be installed at the same time to correct toe adjustment. Toe specification for the rear wheels is 0 toe plus or minus 3/64. This specification is for all models with all types of tires. With the vehicle on a flat surface, ride height okay and tires inflated properly, measure the toe of both sets of rear wheels. You can use the centers of the tread for reference points or the inside of the tires or wheels. However, use the same reference on both sets of wheels. If you're using the tire tread center, spin the wheels on the hoist and scribe the tires to establish the tread center. Then, on the floor, roll the vehicle back and forth several feet to remove any slack due to looseness in the bearings and bushings. Now, make the measurements and write down the toe for both sets of tandem wheels. If the A and B distances are within 60 thousandths of an inch, front tandem toe is okay. Likewise, the rear tandem measurements C and D should be within 60 thousandths. Now, if the toe is off, there is a new procedure for determining which side of the vehicle is causing misalignment. Drive the vehicle straight forward onto a level surface and remove the wheel covers and outer dust cap. Start on the side you think has the misalignment. Place a straight edge across the face of the wheels along the center of the frame rail. Then, measure the distance from the straight edge to the frame rail at the front of the forward tire and the back of the rear tire, as indicated by A and B in this diagram. Again, the measurement should be within 60 thousandths of an inch. If they're not, this is the side to shim to correct the toe. If it's okay here, make the same check on the other side of the vehicle. Then, having located the points of misalignment, you are ready to shim to correct camber and toe, so that camber will be 0 to 1/2 degree positive, and so that the sum of front and rear tandem toe measurements is 0. With the vehicle raised off the floor, loosen the 6 bolts on the appropriate suspension mounting bracket or brackets and insert the shims as required. For camber correction, 8 shims are equal to 1 degree. In other words, each shim is the equivalent of 1/8 of a degree. So if camber was 1/2 degree negative, for instance, it would take 4 additional shims to set it to 0. The toe shims are equivalent to 1/8 or 125 thousandths of an inch of toe adjustment. So add as many vertical shims as required on the faulty side of the vehicle so that the A and B measurements are within 60 thousandths. After shimming, tighten the 4 retaining nuts on the frame rail to 65 to 85 foot-pounds torque and the nuts on the cross member 50 to 60 foot-pounds. Then lower the vehicle and recheck the alignment, both camber and toe. Remember that the front and rear toe added together should equal 0 or nearly 0 within 3/64ths of an inch. If they don't, refer to the table in Bulletin 76 IM5A for additional shimming to get the toe adjusted properly. After the rear alignment is corrected as required, next check the steering gear for adjustment, binding, and centering. Operate the steering in both directions from stop to stop. Feel for any looseness, kickback, sticking during a turn, or poor returnability. Follow the recommended checks and corrections in the maintenance manual for any problems in the steering gear. That concludes the suspension, steering, and tire wear diagnosis procedure. To summarize, you should always begin with a preliminary inspection of all moving parts to check for binding or looseness. Then, inflate the tires to the correct pressure. Check and properly adjust ride height. Check shock absorber control, and measure tire and wheel runout or wobble. Check the brakes for dragging, front wheel bearings, ball joints, all steering linkage connections, and the steering gear operation. Analyze the tire wear as a clue to the need for alignment, and remember that intermediate rod parallelism must be correct before aligning the front end. Finally, check the rear suspension bushings for wear and replace them if necessary. Check the rear suspension camber and toe and make the necessary adjustments. Be sure to refer to Technical Bulletin 77 IM2 and its references in the maintenance manual and other bulletins as a guide for this procedure. Also, the bulletin contains several pages of diagnosis charts related to specific problem conditions with their probable causes and corrections. Following these approved procedures will enable you to diagnose and correct suspension, steering, and tire wear problems the first time and to full customer satisfaction.